So I just wanted to create a quick video on the CreateFileW Syscall, having a look at what it looks like in a disassembler, what it looks like in a debugger, and then looking at what it is in its respective code. How this executable here, it is a 32-bit executable. You can analyze it in PE Studio. It will analyze the portable executable. You can see that it is 32-bit, entropy of 5.3, and we can see 4D58. It is a executable. We have the hash. We also can look at the imports and see, right, what is it importing, grabbing, that's going to be used within this PE. You can see the use of CreateFileW, which is the import that we are interested in. We can also see some other which have been flagged as malicious, srand, rand, terminate process, etc. If we look at the strings, we can also see the strings that have been extracted from the executable. You can see the use of srand and rand again, the string createfile. If we scroll down, we can also see the PDB. We can also see a string that's been declared, percent app data percent. We can also see this program cannot be run in DOS mode, and then some random strings, as well as a dictionary. So looking at this, we can kind of gauge a good understanding of what this executable will do. Next best thing to do is to run it. So if we run this executable, nothing happens. We could load up Process Hacker. We could load up regedit. We could see if this is doing a registry, any processor being spawned. We could load up Wireshark, see if it's doing any network connections. But we know what this is. I know what this is, and you're about to find out what this is. So what this does is, when it's executed, it is just creating a random file in the app data directory. It's creating a random 8-character file. So the question is, how do we determine what the file is going to be made? How do we determine, if we didn't want to run it blindly, what this would do? If we wanted to run it in a controlled environment, if we wanted to statically look at it in a disassembler, how do we know what this does? So first what we're going to do is we're going to put it in a disassembler. I'm going to use IDA. So we know that this is a 32-bit, so it's going to be using the extended general purpose registers. This is just asking us if we have a PDB file, which we don't. So it loads up, it finds the main for us. We can see that variables are declared at the top. We can see file names declared, destinations declared, argument count, vector, and environment pointer. See the function prologue, we can see that the base pointers pushed, we can see that the stack pointers moved onto EPP, and then we can see that some room is being created on the stack, 460H. So we can see that the use of some calls are being made. We've got the data segment underscore times 64. We can see srand is being called as well. Don't know what these are, you could just search them up. We can then see our first syscall. So we can see that data segment expand environment string is W, and then we can see that there's these 3 pushes onto the stack prior to the call. So before a syscall is executed, parameters need to be pushed on the stack, so these could be declared. So for example, we're declaring the size, dest, and the directory. But if we want to see what it looks like in MSDM, which is Microsoft documentation, we can just type in expand environment string is W. You can just type it in Google, and it will come up. So it looks something like this. It gives you the name of the function, as well as a description of what it does, and then the syntax. So you can see that expand environment string is W. These 3 parameters need to be pushed onto the stack: the source, the destination, and the size. So we can see that this is pushed in, size, destination, and source. Works in a LIFO, the stack, last in, first out. So that's the reason for the parameters being pushed different to what it looks like in MSDM. See that the size is first, and then the destination, and then the source. So we know that the source is app data app. So that's the directory that we saw that the file was pushed in, or is being declared to be pushed in. That function is called. We're testing EAX and EAX, and then if it's successful, it'll go to here. If it's unsuccessful, we'll go down to here. We can rename this if we wanted. Right click, rename, and we can do unsuccessful. So on the basis that it's successful, this will now be, this box will occur, this sub function. We can see that we've got EBX pushed, ESI, EDI, so we know this is memory transfer, source index, destination index. We can see that this value has been pushed into ECX. This EBP plus var underscore 50 variable load effective addressing is being loaded into EDI, which is a destination memory transfer. And then we can see that this dictionary is being pushed into ESI. So we know that there's going to be some memory transfer, some computational calculations happening with this dictionary. It's just setting this up. And then we can see that the RAND, the data segment RAND, is being pushed into EDI, XOR in ESI to make it 0, and this value is being moved into EBX. This is basically setting up the loop. So we have this function here, we can rename it, we know what it's doing. It's got a box that's going round and round. We can see a comp, a compare, and we can see an increment. This is likely what a loop would resemble. So we can rename this function and put it loop. So we know that what this loop is doing is generating the name of the file. We know that two ways. When we run it, an 8-character file was made. So we can see that EDI is being called, which is the RAND function. We're XORing EDX and EDX at 0, dividing EBX, doing some moves, and then incrementing ESI and comparing 8 to ESI. So ESI is going to be storing the length of the file name. If that's successful, this function is now being moved on to this function. You can see another function, sub underscore 401010. We're not interested in that, we're interested in the CreateFileW function call, Syscall. So we have a CreateFileW, we see that these parameters are being pushed onto stack prior to the call. So if we're unsure what a CreateFileW does, we can just look at it in MSDM. So CreateFileW function creates or opens a file or input-output device. So we can basically see the parameters that need to be pushed in for the CreateFileW to work. These are optional. You can see the file name, the access, share mode, etc. So like before, the first one that would be pushed into the code is the last one that is pushed in onto the stack. So we have the file name, which is what's in EAX. What's in EAX? We've got EBP plus file name is load effective address moved into EAX. This is moved into EAX, and we can also see that EAX is also pushed into here, the buffer. So we know that the CreateFileW, the return value, is going to be stored in EAX. So what we can do is hit a breakpoint on CreateFileW, look at the return register, which is EAX, and basically see what happens. So if this is successful, the file is created, and then popping, removing EDI, ESI, and EBX, and then moves into this box, which is doing the function epilogue. So we've seen what it looks like in a debugger, disassembler. Let's see what it looks like in a debugger. Let's see if we can catch the file being made in real time, and look at how to analyze this in a debugger. I'm going to open this in X32Debug. We know it's a 32-bit program for the use of the EAX, the extended registers. So what I'm going to do is I'm going to look at the breakpoints. We have a breakpoint already. That's on the entry point. At the moment, we're in ntdll.dll, so we're not actually, these instructions are not the instructions for the create file application. We're in a DLL, a native DLL called ntdll.dll. Just to be for a brief background of what this basically looks like, we've got the offset in memory, we've got the opcodes in hex, we have the CPU instructions in assembly. Here we have the registers, we have the general purpose registers, we have the segment registers, we have a hex view, and then we have the stack. These are basically the main components of a debugger. So what we can do is we can create a breakpoint. We know that CreateFileW is going to be called, so we can hit a breakpoint on CreateFileW. See that breakpoint is set at this memory address. We can run. We can see that a breakpoint has been hit, int3, interrupt3, breakpoint, entry breakpoint. So we've hit the entry of the application. All this code after is the code for the application. We know that because we're in the module CreateFileW.exe, which is the name of the file, and then we're in the thread that's being used. So if we hit a breakpoint again, we're going to hit CreateFileW. So what we've done is we've reached the code up to CreateFileW, and we can see that we know that looking at the disassembler, the EAX value will hold the name of the file, the path in the file that's going to be pushed into CreateFileW. So we can see up here the path of the file. We can also look at this in the hex view by right-clicking, following dump, and then we can see it in wide ASCII format. We can see that we have users, analysis, app data, roaming, and this is the name of the file.txt. So to see this work in real time, we can execute till user code using this button up here. So by looking at it, we know that this file is going to be pushed into CreateFileW, and this is the random 8 character file that's going to be created. So if we execute to user code, once the app data, and then we can see that this file was created. We still have the hex view output, so we can see that this is exactly the same file. So that's how we use one breakpoint on the function call to see what is being done in a debugger. Obviously, this is a very, very, very basic way of using of how someone would use CreateFileW if they were to have malicious intent. Next, we're going to have a look at what the code looks like, the source code of this written in C. Very simple, only about 45 lines of code, 46 lines of code. We have a function here that generates a random string. We saw in the string section this dictionary. It's just a dictionary of characters, numbers, uppercase. We then see the function syscall expand environment string w, the updater that was declared, which is where the file is going to be stored. We then see a random file name 9, so this is going to be generating the random file name. We're using the generate random string. It's going to give it a random file name, the size of random file name, which is this. We then see the CreateFileW, so we're getting a handle to H, CreateFileW, and we see that these are the parameters pushed into CreateFileW. We've got the file path, permissions, generic read and write, etc. Then we've got some error handling here, and then we're closing a handle to H, and H is CreateFileW. This is basically what the source code is. Very, very simple. There is no obfuscation of the API calls. It is just a generic syscall. More technical source code will have obfuscation, whereby the function calls are done dynamically during runtime. So that is what we'll be going through next. In the next video, we'll be going through get proc address and load library A to dynamically load function calls, so they're not plainly in view when looking at the imports. So that's what we'll be looking at in the next video. But hopefully that's helped you understand the CreateFileW syscall in Windows, as well as what it looks like in a disassembler, what it looks like in a debugger. Thank you.